It is a little after 2 in the morning, somewhere in the Philippine Sea, and the submarine is on the surface because she has no choice. Her batteries are flat. The diesels are running hard to charge them. On the bridge, 4 lookouts sweep the horizon with what were, by any honest measure, the finest night optics in the world. Below them, in the radio room, a receiver sits silent. That receiver is the boat's radar warning detector, and it is working exactly as designed. It is telling 90 men that nothing out there is looking for them. 11 miles away, an American destroyer has been tracking them for 20 minutes. That gap between a warning system reporting safety and an enemy who has already found you is the story of the Japanese submarine force in miniature. Not one broken component. A philosophy of design that produced a boat beautifully engineered for the wrong century of warfare. To see how it happened, you have to start with what these submarines were actually built to be. The Imperial Japanese Navy did not think of the submarine as a raider that vanished into the shipping lanes. It thought of the submarine as a scout and a skirmisher for the battle fleet, a warship that happened to submerge. It would range thousands of miles ahead of the battle line, find the American fleet, radio its position, and whittle it down before the great daylight gun duel that everyone in the Japanese naval staff believed would decide the Pacific. Every design decision followed from that, and every one of them traded away the thing that actually keeps a submarine alive. Start with size. A boat that scouts the whole Pacific needs enormous range and enormous fuel bunkerage, so the standard Japanese fleet submarine displaced well over 2,000 tons submerged, roughly double a German Type 7. The B-1 class, the most numerous type Japan built, ran 108 meters from bow to stern. And because a scout needs to see over the horizon, many of these boats carried a floatplane, which meant a watertight hangar and a compressed air catapult bolted to the forward deck. Picture that for a second. A long cylindrical hangar and a launch rail sitting on top of a submarine in the open sea. That hangar cost them 3 ways at once. It added drag, so the boat was slower submerged and drained its batteries faster. It added a large, hard, flat structure that returned radar energy beautifully. And it added free flooding volume that had to fill with water before the boat could go down. Which brings us to the number that killed more Japanese submariners than any other: dive time. A German Type 7, run by a drilled crew, could get from surface to under in something close to 30 seconds. American fleet boats managed roughly 35 to 40. A Japanese fleet submarine of the same era needed somewhere between 50 and 60. 20 seconds does not sound like a weapon. It is one. An aircraft spotting a surfaced submarine at 5 miles closes that distance in well under a minute. Those 20 seconds are the difference between a boat that is 100 feet down and hard to find and a boat that is still half on the surface with her conning tower awash when the bombs arrive. Multiply that by every patrol, every day, every horizon for 4 years. The arithmetic is not survivable. Then there is the noise. Silence in a submarine is not an accident of construction. It is engineered, deliberately and expensively. Machinery mounted on rubber and spring isolators so vibration never reaches the hull. Pumps and hydraulics chosen for quietness over power. Decks decoupled from the pressure casing. The Germans worked at this. The Americans worked at it and kept working at it after the war. Japanese boats were built hard-mounted. Auxiliary machinery bolted more or less directly to structure that was in direct contact with the sea. Allied sonar operators noticed. Reports from destroyer escorts and hunter-killer groups repeatedly describe Japanese submarines as loud, detectable at ranges that made an approach easy and an escape close to impossible. A boat that cannot be quiet cannot break contact, and a boat that cannot break contact only has to be found once. And then the failure that sits underneath all the others. Japan lost the electronics war before it started. 1942, American destroyers were carrying SG radar, centimetric, meaning a wavelength of about 10 centimeters, generated by a cavity magnetron. It could pick a surfaced submarine's conning tower out of the sea return at 10 miles, in total darkness, in rain, at a range where the finest night optics in the world are looking at nothing at all. Japanese submarines did not carry usable surface search radar until 1944, and when it arrived, it was heavy, fragile, and prone to failure at exactly the moment it was needed. But the deeper problem was the countermeasure. Japan fitted radar warning receivers, sets designed to detect an enemy's transmissions and warn the crew they were being swept. Those receivers were tuned for metric wave radar, the long wavelengths Japanese engineers knew about. Allied centimetric radar was outside the band. The receiver could not hear it. So the set did not fail loudly. It failed silently, and it kept failing silently for months, while crews across the fleet learned to trust a green light that meant nothing. That is the worst category of engineering failure there is. Not a system that breaks, but a system that reassures you while you are being hunted. Men surfaced to charge batteries because the detector said the sea was empty. Some of them found out otherwise in the 2 or 3 seconds it takes a 5-inch shell to arrive. Behind all of this sat an industrial failure that made any of it almost impossible to fix. The United States built submarines the way it built everything else in that war. A small number of standardized designs, produced in volume, in parallel, at multiple yards, with interchangeable parts and a common training pipeline. When a fault was identified, the fix propagated across the entire class. Japan did the opposite. Over the course of the conflict, the Imperial Navy built dozens of distinct submarine types: cruiser submarines, aircraft-carrying submarines, transport submarines, small coastal boats, midgets, purpose-built cargo carriers for the Army, which ran its own submarines because it did not trust the navies. Some classes numbered 20 boats, some numbered 3, some numbered 1. The result was a fleet with no economies of scale, no common spare parts, no fast route from a lesson learned to a fleet-wide refit. When the answer to the radar problem finally became clear, there was no mechanism to push it out to 200 boats, because those 200 boats were not 200 of anything. They were a museum. Now, here is what makes all of this genuinely tragic rather than simply a story about a country that could not build things. Japan could build things. The Type 95 torpedo carried by these submarines was propelled by pure oxygen, ran effectively without a wake, and delivered a warhead further and faster than anything in the American inventory. It was, weapon for weapon, the best submarine torpedo of the Second World War, and no one else had anything close. The engineers who produced it were world-class. They were simply pointed at the wrong problems. Enormous effort went into range, into armament, into the aircraft that a scouting submarine would need. Almost none went into acoustic isolation, into rapid diving, into radar and radar detection, the unglamorous survival engineering that decided who came home. You can see the entire philosophy taken to its logical conclusion in the I-400 class. 6,500 tons submerged, over 120 meters long, 3 floatplane bombers in a hangar built into the hull, a catapult on the foredeck, and enough range to circle the globe 1.5 times without refueling. They were the largest submarines built by anyone, until the nuclear missile boats of the 1960s. They were also the most expensive way ever devised to build a target, and they were finished in 1945 for a war that had already been decided. The bill came due in the numbers. Of roughly 200 submarines Japan operated in the Pacific, 128 were sunk, a loss rate around 64%. About 10,000 men served in the force. An estimated 3,500 never came back. And in exchange for all of it, Japanese submarines sank 184 Allied merchant ships across the entire war. German U-boats sank roughly 2,900. There is one last detail, and it is the one that stays with you. In the final year of the war, Japanese designers built the I-201 class. Fully streamlined hull, all-welded construction, deck gun deleted, everything fared in, an enormous battery. A boat that could make 19 knots submerged, faster than it could travel on the surface, and faster underwater than most of the destroyers hunting it. It was, by a wide margin, the most advanced submarine design of the war outside Germany. It was the right answer. Every one of its features was a correction to something that had been killing Japanese crews since 1942. 3 of them were completed. Not one ever went on a war patrol. They surrendered at anchor, were examined by American engineers who understood immediately what they were looking at, and were taken out to sea and sunk. The correct submarine, built by the correct engineers, arriving after every man it might have saved, was already gone. If you found this story interesting, don't forget to like and subscribe. It really helps the channel. Thanks for watching, and I see you in the next story.